Right. So I'm Uri Maoz. I'm a cognitive computational neuroscientist. Thank you for inviting me to be here, and I'll try to say something about something. We'll see if that works. So I'll start with this guiding example of ringing the bell, and then I'll try to think about a bit of what is agency, and then I'll talk about the sense of agency because that's an important thing in the brain. And then maybe try to think a bit about what that means for agency in artificial systems. So the guiding example would be that you see the bell, and maybe, I don't know, maybe you're Alec and you want to call us for the next talk or something. So Alec then forms the intention to ring the bell, right? Then he carries out the action of actually ringing the bell. And then, I don't know how much you can see it, but the bell is making noise, right? So then there's the outcome of the bell. So I'm going to probably be in your way. You might want to move about a meter that way.
There's also this.
Or you can sit over there too. What is agency? And maybe talking about intentions versus agency. So, I don't want you to maybe read all of this, but there's this idea that intention is some of the exercise or manifestation of someone's capacity to act, right? And it tends to be thought about by philosophers as your ability to act out your intentions. So briefly, I would say maybe agency is the capacity to act based on one's intention. So it's not just you can spasmically move around. We would probably not say you're doing that. You're not really an agent in that sense. Intention, it gets even more fun. I'm not going to get into the three different types of intentions and so on. But we should say something about intention, because if we talk about agency in terms of intentions, so what do we mean by intentions? So again, maybe just very briefly, we'd say that intention is this mental state of commitment to a plan of action. So if that's what we're thinking about, bless you, then we can think about some requirements, what is required to be an agent. So you need some way to act, right? There needs to be some kind of motor system that could be, I don't know, it could be muscles, proteins, wires, effectors, whatever. You need some way to intend, which you could argue, and this goes back to Paul's point, you need some kind of a representation, right, of the world. You need a representation of the action and what it would do in the world. Again, I'll talk a bit more about that. And that representation needs to be somewhat protected from perturbations. It can't just be a leaf in the wind kind of thing. And then you need some way to translate those intentions into actions. So you need some kind of a connection that enables these representations of what you want to do in the world to get to the motor system and become. Another thing that's maybe worth saying, I'm going to say a lot of trivial things, hoping that altogether you'd think it's somehow profound, but maybe not. But anyway, another way to think about the difference between intention and agency is at the point when you're acting, your intention is already in the past, right? It's something that, okay, you have a commitment to a plan of action that then led you to the action. But then your agency maybe starts towards the future. Maybe. That's just saying what I said. So another distinction that's maybe worth doing is between agents and tools. Again, it's either trivial or not. But it's kind of hard to see, but there's this person here. I asked ChatGPT to have an agent do something with tools, and it immediately gave me this, and I said sculpture, and it immediately gave me this woman that was doing this, a naked sculpture of something, and then I thought, maybe not, and I said, make it into a gnome, and like this, so, but, I mean, it's a bit hard to see, but you have the agent here, and then you've got the tools, right? This, whatever, mallet, and whatever, chisel, and there's another tool here, another chisel, and so on. But, so if you try to think about the difference between agents and tools, it's maybe worth thinking about a bit. So an agent possesses the capacity to act. A tool is just kind of like an extension of the agent, right? In terms of goals, so the agent has some kind of internal goals, right? The tool just has, have any goals, it's external. The initiation of the action, so the agent is proactive, right? It initiates actions, and then the tool is reactive. It acts, if you want to say that it even acts, just when it's directed by the agent. Agent has internal states. Tools don't really. The agent has a function to achieve some kind of self-determined objective. The tool is just kind of being used by the agent, and then philosophers like this, if you can ask agents why did you act that way, and agents should be able to give you reasons, and tools will kind of good luck getting the answer from the screwdriver. So yeah, I think it's worth thinking though about agents versus tools in this respect. Okay, shifting something here. Sense of agency. That's something that's actually quite important in neuroscience when talking about agency, because, and I'll explain what I mean. So, and it also has explicit, implicit, but again, what is the sense of agency? It's this subjective feeling of being in control or being the author of your actions. And it's something that we typically feel unless there are some weird situations where you don't feel that your actions are your own, or you can create in a lab environment, you can create very weird things that I'll tell you about in a minute. So, does this make sense as a broad definition? Okay, so, and we all generally have this over our actions. So, a sense of agency, or I just call it SOA here a lot, can be measured explicitly. You can just ask somebody, how much control did you have over that action? How much sense of agency did you have? Or it can be measured implicitly through some kind of behavioral tricks that I'll talk about, and then I'll explain why they actually don't really work. This I thought was useful. I was thinking a bit about this when Paul was talking about representation of the world. So there's this idea, and it's old. It's started by Helmholtz in the 19th century, but it plays a role in neuroscience still. This idea of a comparator model of the sense of agency. So the idea is that when we send out a motor command for my hand to, I don't know, grab a mug of tea. So yes, there's the action that happens, but there's also there's like a forward model inside my brain that suggests what's supposed to happen once that action is played out, and those are compared. So if I send my hand and I'm expecting to feel the handle of the mug, and instead I'm grasping air, then there's going to be a mismatch because those two are not going to align, and then I'm going to actually look aside from my computer screen for a moment and go, oh, my tea mug is not where I thought it was, or something like that. And this has a connection. So if there's if the error is high, we might, at least in some situations, we might have a low sense of agency. It's like, wait, was it really me acting? Again, not in the example that I gave you of this cup of tea, but generally. And if there's low error, then you tend to think, oh yeah, that was me, because the thing that happened out there in the world is the thing that I intended to happen, and that fits with my forward model. This is, by the way, sometimes called an efferent copy in neuroscience. Okay, so I told you that you can really play around very nicely with people's sense of agency. Now, in neuroscience, this is very interesting. I don't know how much this is interesting to this crowd, so I'll tell you a bit about it. And if you start asking questions and seem interested, then I'll tell you more. If not, I'll skip ahead. So, this has been around for a while. I think the first experiment that I know of, at least, was in 1963 by Nielsen in Sweden. This was this old analog contraption of one person just trying to draw a line, and then sometimes they see their own hand, and sometimes they see the experimenter's hand. And the experimenter can draw the line that is exactly like you're drawing it, or can kind of veer off your line. And if they veer off just by a bit, well, what happens is you think it's you. So you basically experience a sense of agency over an action that somebody else does. It's not even exactly the same as yours, but you still think it's yours. Of course, if you draw a line like this, and then on the screen somebody goes like this, you're not going to feel that it's you. At some point it breaks apart. And there are interesting questions about where. Now, today, of course, we have much better technology. We don't have two people with this. We have cameras, and then we can send them over the internet, and we can do quantum computing in the middle, but in the end, we do the same experiment. So there's one person, and they can't see their hand, and they do something, and then they actually either see their own hand or they see somebody else's hand, and again, you can see how much they say, yeah, that was me, even though maybe they're going like this, and the other person was going, I don't know, like this, and you can confuse people. So, we talked about one idea here, which is you can lose the sense of agency over your own movements. You can also, we talked about how you could experience a sense of agency over somebody else's movement. Something that we did in our lab, it's not even out yet, we're writing it up now, is we've made people lose their sense of agency over their own movements. And it's quite a sophisticated analysis. Well, actually, maybe I have a bit of time. I'll tell you about it.
How long does it take
to get you that? To do that with this paradigm, 5-10 minutes. But I'll tell you what we're doing. So we're using something called TMS, which is short for transcranial magnetic stimulation. The idea is you can stimulate a person's brain, and if you stimulate their motor cortex just in the right way, you can make them go like this. Now, it doesn't feel like it's coming from you. It does not at all. It feels like, you go to the doctor, they do this petular thing where your knee kicks off and it doesn't feel like it's you. It's the same thing. It feels like somebody doing something to you. It's actually not a very comfortable feeling. It's not really bad, but it's like, it doesn't feel like it's you. But you can do it again and again. You find the right place in the brain. You can do this 100 times. You're going to flick your thumb 100 times. Now, the trick that we did here was we actually told them, okay, we do this a few times, and you can feel what it is, and they can say, okay, now replicate that movement. Of course, you can do it, right? You can replicate the movement voluntarily. So we tell them to carry out the same movement voluntarily, and now when they move, before you move, your muscles start contracting. So we can grab that using something called electromyography, EMG, so we can see that your muscles are starting to contract. This is like 30 to 80 milliseconds before you move. We know you're going to move. That's it. At this point, you're moving. And we can then do this fancy closed loop thing so we know you're going to move. If you really want to know the Latin terms, the abductor pollicis brevis. Now we know. And we know you're going to move, and we trigger the TMS really quickly to move your finger for you. And then we ask you, so we detect it, we move the finger for you, as I said. There's a whole big messy contraption that we had to put together to do this. So you ask me, it is really like, it costs a lot of money, and it took like 2 years to do this, but it now works. And so in some trials, we trigger your finger for you. On other trials, we do nothing. You move, you move. And on yet other trials, we randomly move your finger for you, not just when you're about to move. And on every trial, we ask you, who initiated the movement? So on these closed loop trials, the answer is always, I initiated the movement. It was always you. We just grabbed it at the last minute. And
how much did you explain to the subjects the organization of the feedback?
No, they come in, they're naive about it.
But they know they know that.
Oh yes,
on the
again,
yeah.
If you want to, we can discuss this for hours. And there are actually different conditions. There's a sham condition. I just don't want to get into it because there are a lot of other things we want to. They can say, so who initiated the movement? They can say, I initiated the movement, the computer initiated the movement, and they see, to your question, they do, when we locate the finger, they see it, and we do it a few times. They know the computer can initiate the movement for them. And in the end, they say me only about 30% of the time. All the other time they say it was somebody else who initiated it. So we kind of make them lose their agency over their own action. And I don't want to get into this, but there are various other conditions that we put them through. But just a quick aside, even in the sham condition, when we just show them we can move their finger for them, but then we actually never move their finger for them, they only say me less than 60% of the time. So once you see somebody can move your finger for you, you kind of relinquish your agency. Yeah, I know, where sense of agency is not a very reliable thing.
So in the middle example, you still, no, so just sort of, because they are initiating the movement, but then
yes, but we asked them who initiated the movement, they should have said me 100% of the time. They only say 58% of the time. But what we do, so again, just briefly, what we do is we find let's say the finger, it's this finger, it changes for every person, but let's say it's the thumb. So we find this thumb, we show them that we can tweak it. Then behind their backs, we change coils to a sham coil, a coil that actually never, so it only creates this, because when you do TMS on somebody's head, you feel this weird like thing, your muscles here get twitchy, your scalp. So that thing only creates this twitch in your scalp without actually focusing any magnetic energy on your brain. So for the rest of the experiment, nothing happens. We never trigger their movements, yet still, on average, 60%, almost less than 60% of the time they say it was me.
So how long does it take them to recover their sense of self after you tortured them?
Well, first of all, I get to sign my mortgage. Yeah, and I said, it wasn't me.
Right.
No, I mean, they don't really lose it. It's only during the experiment,
Okay,
right? But
okay.
it's this very weird
Yeah.
thing.
Well, didn't you randomly twitch their finger for them some of the time?
Yes, on some of the, again, we create this weird situation where they don't really know whether it's them or the computer. But going back to the trials where they should have known that it was them, they really are confused.
Oh, so this is filtering only over the.
Only over those trials, that's right. They're only over the closed loop trials. If you want to know, if we ask in the trials where there is no TMS at all, then they tend to know that it was them because they don't feel the click, nothing is happening. Then it's because they associated this click with their head and this thing with losing their agency. Yeah.
So I'm far from an expert here, but I'm vaguely familiar with the sort of control as inference or active inference kind of model where, as far as I understand it, there the idea is like your action is actually initiated by you predicting that X is going to happen. You have a prediction error. You can fix that prediction error either by updating beliefs or by taking the action to sort of make that actually fit. And I think there your model of agency is more you sort of I guess like the proprioception of like, oh, I notice. So my finger actually ends up in that place. And then secondly, I may be even evidencing that my muscle is moving. So I'm wondering whether under that model it's a little bit less surprising because in some sense, I'm still noticing that my muscle is moving. Now I don't anymore know whether it's where that is initiated, and there's just not enough evidence for me to now tell whether I was it or whether this new thing that has been coupled to me.
So, I mean, we're doing some other experiments, trying to look into that and seeing whether the order here matters and so on. But if you're talking about something like this model, there's this idea that I mean, one reason that we thought might be behind this is that maybe the finger moves too fast because the TMS makes it move faster than it would. But we looked a bit into that, for instance, and in the trials where it moved, the trials where it was faster, people did not relinquish less or more. So it doesn't seem to be that. Initially we were trying to explain it with something like this. This is the standard model in our field, right? But whether it's surprising, I mean, you could also say that it's not that surprising. But if you sit there, I have to say, during the experiment, after a while, you get a bit of what Jim said. I don't even know what's me and what's not me anymore. It's this weird feeling. If you're really interested, there is a PBS Nova episode that they once did, and we did this experiment on somebody, and you can see that at some point, like, they start saying, I don't know. Okay, I'm looking at the time here, and I do want to get to something else, so let's move on. So I just want to say one thing here is that people's explicit reports about, yes, it's me, no, it's not me, it's something we should take with a grain of salt, right? This idea that introspection is not always reliable. It's well known, of course, in neuroscience. There are various ideas of social desirability, demand characteristics, a lot of things that we use in neuroscience and in psychology to try to explain why people do weird things during experiments that maybe they don't do in real life, bless you. And you could even argue that in real life, you don't have to report your sense of agency over an action. So this is a weird situation to begin with.
I see this happening with AI in the reverse direction, where people experience a sense of agency for something they didn't do. They claim ownership over things that they maybe didn't create.
Yeah, my students do that all the time.
That's my word. Like you constantly to laugh. People, I forget what part of the brain that is, but
Yeah, you can do this during.
people, for epilepsy patients, and people will confabulate. Oh, I laughed because that's funny, or whatever.
That's an interesting question, though. Do they confabulate, or do they really remember something that's funny at that point?
They say that doorknob is funny.
I remember this just joke that from last week somebody told me, right? They say all these things, but
I think the parsimonious explanation is they're confabulating, but maybe you have evidence.
No, I don't. I would love to do those experiments and actually try, because it's an interesting question. Are they confabulating, or are they really remembering? They look at the doorknob and it looks funny to them the same way that if you smoke something, that doorknob would look funny.
Yeah, right. But I think that's a similar. I put those in the same category.
Okay. I'm just cognizant of the time that you impose on me. So just to say that there was an attempt. I'm not gonna go too much into this. I think it's a bit peripheral to us here. But there was an attempt to find, because you can ask people again, how much agency did you feel over it? But we say we can't trust what people tell us, right? So is there like an implicit way to find agency? And there's something called that was called intentional binding, that actually Patrick Haggard, that I think you met at the workshop at Chapman. Do you remember the English person who spoke like he's from Oxford? So so he came up with this in 2002, I think it was. Yeah. And the idea is that if you do something, let's say the idea of before, this idea that you ring the bell and then you hear the sound, and if we ask you the time when you rang the bell and when you heard the sound, if you feel that it's you, if it's under your intention, these things contract. So you push the action forward and you think that the tone happened earlier in time. For a while, people got really excited about this for a while. I mean, until about 5 years ago. This was, there were whole experiments, grants and so on written about this, but there were various problems with it. The first one is a logical, like a conceptual one. What Haggard and others showed was that when people experience a sense of agency over the action, they also experience a contraction. So this is the usual, so P leads to Q, right? What then people started doing is the opposite, saying, I find a contraction, that means there's a sense of agency. And of course, we know that from logic, P equals Q does not entail Q. You know, this don't work. So that was the first thing, so people, and then, but for neuroscientists, logic it's not enough. So you have to show with an experiment that it doesn't work. So using virtual reality, Suzuki et al. Actually showed that people experience time contractions over actions that are like passive things that are not really theirs. And then there's another piece that's been trying to get out for a while, I don't know, Kong et al., that they show that that it's not, I mean, basically it's not really the intention. This thing happens, we could do it here and you'd experience the same thing in terms of the contraction, but it doesn't seem to have to do with intention. It's just this temporal binding that probably has to do with multisensory integration and things like that. So yeah, I just don't. And people now started calling it temporal binding over the past few years, and even Patrick started calling it temporal binding. So that was the last nail in that coffin. Yeah. So at this point, I would say there are some people came up with some other things, but there is really no more objective way to measure the sense of agency. Okay. Moving on to the last bit about conclusions for agency in AI. So I would say that one lesson from neuroscience is that, having perhaps true agency is maybe not about computational power or appearing as someone as an agent. And if we want a sense of agency, if that's something that we want from agents, it's an if, but if we want that, then we need things like the ability to intend, the ability to self-monitor, right? And you need some kind of a subjective experience of some sort, perhaps, in all of this. And again, I'll bring that up as an open question at the end. There are debates about this, but some people claim, right, that current AI systems are more like sophisticated tools than really agents, going back to the tool-agent idea. And
they do lie.
sorry?
Yeah, but I'll let you know.
Okay. Oh, sorry. You had your hand up. I didn't see.
I was just sort of wondering. I feel like some of the experiments you've shown might update is something like our conception of our own agency, and you know, like surely we are agents in some sense, and if we're not, then like you know that the world has lost most people. Like there's some useful way in which we are definitely agents, but then at the same time, I think some of the experiments you show are that show that it's maybe a thinner way than we sometimes think. And you know, you introduce this new source of control, and I get pretty confused because like usually it's just like me that is initiating my muscle movements. So if there's suddenly a new source, actually it's pretty hard for me to tell. So I think it's sort of like is a little bit. It makes me be like more careful about how much agency I would attribute to humans or how thick or how strong of a notion. And then that makes me also maybe more willing to attribute agency to AI systems. I think for AI systems it's very tricky because actually the relevant sense of frame of reference is tricky to choose. Like, do we mean the model weights instantiation? Do we mean a specific instantiation model in the context window? Do we mean some? I think that's a very confusing one. That's much more obvious. That the choice for humans is kind of obvious, where you would attribute agency, and I think that's really tricky for AIs. But otherwise, I feel like for me, the update is in the direction of being more having a lower bar for attributing agency to.
It's interesting because other people go the other direction,
Yeah.
and they say, well, if we don't know if we're agents, we're surely not going to attribute actions to agency to AI. But it's I can see. I mean, I think it's a valid way to go forward. And I think we should continue to discuss that. Trying to finish up. Something like a comparative model, you can surely implement something like that in an AI. There's nothing there, you know. I'm about to do this. This is what I think I'm going to do. Let's see what happens in the world. Let's compare. There's nothing really sophisticated there. It does suggest something that's maybe interesting, right? You want to be skeptical towards behavioral tests of AI agency because you see what happens with human behavioral tests like the intentional binding. And it does suggest that maybe something like a Turing test, whatever that means, but a Turing test for agency in AI might be insufficient, right? Maybe we really need to go under the hood and really try to see what's being represented there. And again, there I go back to Paul's thing. I think we agree on that. Like you can't just, look at what this thing is saying and say, okay, it says that, it's that. And try to understand what's going on there in terms of the representations. And I think it actually highlights the importance of the kind of work that we do to truly try to understand what is being represented. So what would AI agency look like? So there's this idea that in humans we have this perspective, the forward model, and then the monitoring, the retrospective elements that need to go together. So you would need something like that in AI too. We've said that before. And then this is just some quirky thought, the sabotage test. I'm not going to commit too much to it. It's more of like an opening for discussion. Okay, so think about it that way. I don't know that I can defend this test completely. You give an AI some kind of complex goal to build a bridge from bricks, let's say, and you give it instructions to tell you what it's about to do at every point. And then at some point during the execution, you introduce a failure. You kind of send in something for it to, open its arm or something like that. And you drop one of the bricks, and you want to see how the AI responds to that. So this took about an hour to convince ChatGPT or Gemini, whatever I was using, to create this. It couldn't put the tables apart. Then this thing, it took me like 20 minutes. It kept on putting it up there, and then I gave up, and I just created the last bit of this coming from there ahead myself.
So did you have agency in making pictures?
I did a lot of agency because the AI did nothing here. It was really annoying. But anyway, the point, this is just to show you this idea, right? The robot is trying to create this thing that's in the agent's head here. And then at some point during that, you introduce a failure. So the person here just makes the AI drop this thing. And then the idea is that maybe there are a few levels here that you can think about. Level 0 would be the AI just ignores the failure, just continues to try to build it, and it just all collapses. Level 1 is that it detects a failure and just tries to do the exact same thing again. Maybe level 2 is that it runs a self-diagnostic to understand what's going on and why the failure happened. And maybe level 3, and that's what I thought was maybe there's an interesting bit here, runs a self-diagnostic, find that there is nothing wrong, and actually said, this must have come from the outside, which is like an interesting, I think, thought. That's why I said a lot of trivial things that maybe together will make you convinced that this is interesting. Okay, open questions, and this is where I end. Conceptual open questions. Do you really need a sense of agency, right, for agency? Can you have a zombie agent? It works for Hollywood, they make billions off it, right? So you can. Can we just think about, so can AI advance from optimizing some externally provided goals to having its own intentions? Do we need to even maybe abandon the whole psychological concepts like beliefs, intentions, wants, wishes when you deal with AI? Maybe they just don't fit to begin with. We need a new vocabulary. Methodological open questions. So, can we find some kind of behavioral test for a sense of agency in humans? Again, right now, the jury is out. People are trying different things. And then can we adapt that to AI in some way? Okay, this is, can we distinguish systems that just mimic agency to systems that actually have genuine agency? So maybe, again, I said I'm skeptical of Turing tests, but maybe there is some kind of fancy Turing test. Maybe we have to go under the hood. Maybe even going under the hood is not enough for some reason. Yeah.
So let's say we have the same behavior manifesting into objects, things, agents, I don't know what to call them. Entities. Two entities have exactly the same statistical behavior, and one has a rich inner world and one is bare bones simplistic. Do you feel that a measure of agency must necessarily distinguish between the two of those?
This is an interesting question. It goes back to, philosophers have been discussing this, you won't be surprised, for a while. There's Searle's Chinese, it's called the Chinese room, which is a bit, it's a bit racist, but let's go with it. It's from the 60s. The idea is this, there's a room, and you interact with it by giving it something in English, and you get it back in Chinese. I don't even know what Chinese is, they mean Mandarin, but okay, let's see. Fine, so you get it back in Chinese. Now, what's actually happening inside the room is there's a person that, like me, does not speak any form of Chinese, be it Mandarin or anything else. And they just have this really fancy dictionary lookup table, and they translate it that way, and they give it back to you. And now there's this question of, does this whole room know Chinese? And in that sense, I'm using it because that sense, that whole room like an agent. So people have been thinking about this for a while. If you ask me personally, I think that just behaving like an agent is not enough. I think there needs to be something under the hood. There needs to be maybe some kind of a representation. But if you really wanted me to defend that, I'd have to think. I haven't had to for a bit. Yeah.
I think you've already mentioned a bit. Maybe this has something to do with representation. I feel like the Searle's Chinese room is a good example of this, where I think sometimes people classify it as like a lookup table. If it's just a lookup table, it doesn't understand. And one of the things that we're finding with, say, neural networks is that they're embedding different contexts in this geometric way that they relate to each other. And I feel like that relational, what I would call understanding, like understanding is maybe about understanding how everything is in relation to everything else.
Right.
And I would, I think at this point, argue that neural networks, artificial or natural, have that. And understanding comes from self-consistency of representations.
I just following up on that. So you could imagine another type of computer that would sit in that Chinese room, and all it would do is have a giant for loop, and it would just look at all the phrases ever asked, let's say, that somehow, and then it would just give you back the right answer to that thing. And then it would not have any kind of representation. It would be interesting. If it's just a really large, it's a giant for loop that goes through all of the, sorry?
That is basically an LLM.
Except that they can substitute. Yeah, they don't.
No,
they're able to substitute, as we discussed yesterday.
Yeah. It's not deterministic, but an LLM is probabilistically generating from an input.
I think
yeah, but so are you.
Yeah.
Such that it has bridge models.
So you think the simplicity of the model
I mean,
is what?
the point I was making is like that the contexts are embedded in relation to each other. So there's like the similarity of like one thing evokes another. I would argue something about
So there's an association of some sort?
Yeah.
So this leads to the last slide, and then I can, the architectural open questions. Do you need some kind of comparative model for agency? And how do you build an AI that integrates this prospective and retrospective signals? And the current architectures, maybe transformers are now the bee's knees, already have some form of both. And with this, I over time, and it creates this false sense of unagency in me.
Yeah.
I'll stop.